Hi there and welcome to this video. My name is Dr. Tom Carroll, and in this video I'm going to explain to you in a simple way what is the fourth industrial revolution. Now this video is part of a course called Future Skills Preparing for the Fourth Industrial Revolution, and if you'd like to access the full course, please see the link below which will take you to the course for more details and also give you a good discount on the course. So please enjoy the video, and perhaps I look forward to seeing you on the full course. Thank you very much. So hi there. So what is the term the fourth industrial revolution? So in this lecture we're going to be covering the different industrial revolutions leading up to the fourth industrial revolution, what characterizes each one, and where the term the fourth industrial revolution came from. So by the end of this lecture then you're going to have a good understanding of why we are today at the beginning of a new age of industrialization, the fourth industrial revolution. Now the first industrial revolution spanned from basically 1760 to 1840 and was triggered by the construction of railways and the invention of the steam engine. The second industrial revolution started in the late 19th century and into the early 20th century and was made of mass production, which was made possible by the advent of electricity and the assembly line. So you can think of Nikola Tesla with the invention of electricity or variable current or discovery of electricity, and Henry Ford, which of course is the Ford cars assembly line. So the third industrial revolution then began in the 1960s and is known as the computer or digital revolution because it was catalyzed by the development of semiconductors, mainframe computing from the 1970s and 1980s, and the development of the internet in the 1990s. So the fourth industrial revolution then can have different names in different countries. In France, it is known as l'industrie de la future. In Japan, you often hear terms like e-factory. So depending on where you are, it can have different terms. So let's then look at the fourth industrial revolution. And according to Schwab 2016, it began at the turn of this century and builds on the digital revolution. And it is characterized by ubiquitous and mobile computing, smaller and more powerful sensors, and which are becoming cheaper, and by artificial intelligence and machine learning. However, the scope of the fourth industrial revolution is not just about these technologies, but occurring simultaneously are innovations in a whole other range of technologies, ranging from breakthroughs in gene sequencing, nanotechnology, renewable energy, quantum computing, and others. And we're going to be looking at each of these in detail in this course. Now, the fourth industrial revolution is essentially a fusion of technologies across physical, digital, and biological domains. And these technologies are more broad-based and diffusing much faster and more widely than previous industrial revolutions. For example, it took the spindle 160 years to spread outside of Europe. By contrast, the internet spread across the globe in less than 10 years. In 2018, 4 billion people around the world are using the internet, and nearly 250 million new users came online for the first time in 2017. In 2007, we had the first smartphone. More than 200 million people got their first mobile device in 2017, and 2/3 of the world's 7.6 billion inhabitants now have a mobile phone. So more than half of the handsets in use today are smart devices too. So it's increasingly easy for people to enjoy a rich internet experience wherever they are. And of course, as we'll come to see later, a mobile phone is essentially, or a smartphone is essentially a supercomputer in your pocket. But we're going to look in more detail at what I mean by that. Now, in the fourth industrial revolution, there's a growing harmonization and integration of different disciplines and discoveries. Different technologies are coming together to create disruptive change. Smartphones and other devices are putting out massive amounts of data, and we're going to see later, data is like the new oil. If you have data or access to data, there's so much you can do with that data in terms of monetizing information that you can generate from the data or analysis that you can do on the data. So every innovation becomes a building block for subsequent innovations. So all these technologies are building on each other. The pace of change then is a huge issue, and it's the biggest difference between for example, this industrial revolution and the 1800s. Internet data traffic is doubling every year. As of June 2018, there were approximately 1.89 billion websites in the world. The world's first website was only published on August 6, 1991, which is a relatively short time ago, by British physicist Tim Berners-Lee. And there are 3.95 billion internet users, well, there were by June 2018. Now, the number of people using the internet in China is more than double the population of the United States. So as of the third quarter of 2018, Facebook had 2.27 billion monthly active users. Remember that Facebook started in a college dormitory by Mark Zuckerberg, which I'm sure you've heard of, only in 2004. So this kind of gives you an idea of the pace of change. But the thing is, the pace of change is also accelerating. It's getting faster and faster. And change is hard to predict as it's exponential. So we tend to think as human beings in a linear way, but exponential change can take us by surprise when things double and double and double. Now, there are two key laws which underpin the fourth industrial revolution. Now, at least these are two of the key laws anyway. And one of them, the first one, is Moore's Law. Now, Gordon Moore is one of the founders of the company Intel, which makes microchips. And he coined Moore's Law in 1964 when he observed that the speed of computer processors was doubling every 2 years. Now, he revised in 1984 and said that the computer power was doubling every 18 months. And in 2001, he said it was doubling every 12 months. And internet data has also been following Moore's Law and doubling every 2 years. Now, there's another key law. It's called Metcalfe's Law, and it's coined by Robert Metcalfe, the inventor of the Ethernet. So Metcalfe's law states that the value of a network grows by the square of the size of the network. And the idea behind this law is that a network's value is increased as the size of the network increases. So this law is often referred to when talking about the internet's value. So this is what gives rise to platform companies like Facebook. So the more people, for example, that are on the Facebook platform, the more valuable it is. Now, if you look at Facebook's competitors, do you know, for example, who Facebook's competitors are? Have you ever heard of Diaspora, Trustworks, or Snabo? I certainly hadn't. So that gives you an idea of Metcalfe's law, because you don't want to be on a network where there's very few people. You want to be on the network where everybody is, where there are billions of people, such as Facebook, because that gives Facebook its value, according to Metcalfe's law. Okay, so we have been through a number of different industrial revolutions, just to recap, and experts agree that we are now at the beginning of a new industrial revolution, which is characterized by the convergence of many new technologies built on a digital platform. And we can see that we've heard that the pace of change is increasing. Now, here's a quote from Ray Kurzweil. The future will be far more surprising than most people realize, because few observers have truly internalized the implications of the fact that the rate of change itself is accelerating. And that's Ray Kurzweil. and that's from The Singularity is Near, which is a book by Ray Kurzweil, who is a futurist. So we're going to be coming back to all these concepts as we go through this course, but this is introducing them. But when we start looking at all these technologies, such as computers themselves, we'll be looking at computer processing power in more detail, and these laws will apply. So in the next lecture then, we're going to be looking at why should we want to learn more about the fourth industrial revolution? Why is this a big deal, and why should you want to know about it anyway? Okay, so I hope you enjoyed that lecture, and see you in the next lecture. Thank you.